Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video we write C++ code solution for LeetCode problem number 54, spiral matrix. So before we begin, it is a request to please subscribe to my channel. So this is the question. Take a minute and give this a reading. Alright, so they have given you a 2D array, a matrix, and you have to print the elements in spiral order. Okay, so suppose this is the 3 into 3 matrix. This has element 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you have to traverse it in a spiral order, in this order. Okay, so if you apply this spiral order into this matrix, the order of elements come out to be this. Okay, go from left to right, top to bottom, right to left, bottom to top, and again left to right. So in this order, the elements that come out are, okay, you have 1, 2, 3, okay, then 6 and 9, then 8 and 7, then 4 and 5, okay, and you can confirm this with the sample output 1, 2, 3, 6, 9, 1, 2, 3, 6, 9, 8, 7, 4, 5, 8, 7, 4, 5. Okay, so the first point is all elements printed only once. Okay, and why am I saying that? Because when you move from left to right again, okay, this is your left to right movement, you say 1, 2, 3, 1, 2, 3. When you go from top to bottom, you don't have to cover this element 3 again, and that is why in the top to bottom movement you start with 6 and you end up at 9. So you have 6, 9. Then from 9 to 7 you're already covered 9, right? So you don't have to cover it again. You print 8 and 7, 8 and 7, and then you go from bottom to top. You have already covered 7, you have already covered 1, so you just print 4. And then you go from left to right, we only have one element, which is 5. Okay, so all elements printed only once. That's a key point here. Okay, now let's try to observe this spiral order. This is the order that we have. So you can divide this spiral order into spiral order. First is left to right. Second is top to bottom. Okay, third is right to left, and fourth is bottom to top. Okay, so your spiral order is made up of, this spiral order is basically 1 left to right plus 2 top to bottom plus 3 which is right to left plus 4. Okay, and repeat. So after you are done with bottom to top, you go to left to right again, which we saw in when we were covering this element 5. Alright, when you're going from left to right, you're basically traversing a row. So I is constant. I is constant and j increments. Okay. Similarly, when you're going from top to bottom, your j is constant. Okay. And your I increments. Okay. Your I plus plus happens, j remains the same when you're covering a column from top to bottom. Okay. When you go from left to right, your I is constant, okay, and your j decrements. Okay, j minus minus. Similarly, when you're going from bottom to top, your I decrements, okay, and your j remains constant. Okay, so in your key points about this is your spiral order, okay, is made up of 1 plus 2, which is left to right plus top to bottom plus right to left plus bottom to top. These 4 movements in repeat. And we know that the order is starting from 0, 0. Okay, this order starts from the very first element. Okay, so knowing about this idea of this spiral order that can be divided into these 4 movements, and the fact that all elements have to be printed only once, we need to find the right code that fits all of it. Okay, so we start traversing the first row from left to right, which starts at 0, 0. So in this case, you have 0, 0, 0, 1, and 0, 2. Okay, I remains constant at I equal to 0, and j increments from 0, 1, 2 till 2. So you cover 1, 2, and 3, these 3 elements. Okay, when you're going from left to right. Okay, when you're going from top to bottom, you start at 6. So I starts at 1 and j starts at 2. j remains the same, I increments, so I takes, j remains at 2 and I takes 1 and 2. It stops here, so you cover elements 6 and 9. Similarly, when you go from right to left, you start from this element 8, which is at I equal to 2 and j equal to 1. J decrements, so j takes 1 and 0. Okay, and when you go from bottom to top, you start from 4, which is I equal to 1 and j equal to 0, right? I has to decrement, but there is only one element because you have already covered 1 and already covered 7. So 4 is the only element that you get from this bottom to top movement for I1 and J0. Okay, this movement covers 3 elements, these 3. Then this movement covers 2 elements, which are these 2. This movement I2 and J10 covers these 2. This bottom to top covers only 4. So after these 4 movements, you start with this left to right thing again. Now in this case, we are at I equal to 1 and j equal to 1, and this is the only element, this element 5 is the only element that we cover. So after left to right, we have covered all elements. Okay, so stop when all elements printed. Okay, so key points, we follow the spiral order, left to right, top to bottom, right to left, bottom to top, and again the same order until all elements are covered. Okay, making sure we manage the indices the right way, that all elements are only printed once. Now how do we do this? My next observation is that when I have this left to right movement, I have covered a row. So you see this entire row has been covered in the left to right movement. Okay, similarly when I move from top to bottom, I have covered a column, all elements of a column without repeating. We have to make sure we don't repeat the element. That's why this element 3 is not repeated. So 3 was already printed in this column 2, this column with index 2, j equal to 2. 3 was already printed, 6 and 9 was covered. So top to bottom will cover a column. Similarly, right to left will also cover a row, and bottom to top will cover a column. Okay, that is to say that if I start with my row min as 0, row max as m minus 1, which is going to be 2, column min as 0, column max as n minus 1, which is going to be 2. Okay, m into n. It is not always square, it's given in the question, right? M into n. Okay, so when I cover left to right, I'm covering a row. So I've already covered a row, so I don't need to take that into account. So after left to right, your row min increases by 1. Okay, so when you go from left to right, increment row min by 1. And if you think it logically, we are incrementing row min by 1 because we have to cover the entire elements between these indices, row min, row max, column min, column max. When I have covered my first row, I don't need my first row anymore. So the matrix in consideration that I have after covering my first row is this part only. Okay, so basically I just need to cover this submatrix now, which is original matrix minus the first row, and that's why we say increment row min by 1. So now row min becomes 1. Okay, that you don't have to bother about row with index 0 again. Similarly, when you move from top to bottom, you cover one column, so you decrement, you have used this column, right, j equal to 2, you won't need that column again, so you say decrement col max by 1, so column max by 1 is decremented. Okay, so within this submatrix that we have another submatrix, which is this one. Okay, first row covered, last column covered, row min plus plus, column max minus minus, right? And this is what we are left with. Then when we go from right to left, okay, we have this movement, right to left, we cover another row, so we say decrement row max by 1. Okay, since we have used this row, we will not be needing this row again. So row max now becomes 1. Okay, so your array that you are left with is something like this. You are left with this part now. Okay, and this matrix is defined by I equal to 1 and j equal to 0, 1. I equal to 1 between row min and row max, and j equal to 0, 1 between column min and column max, which we can see. Okay, so as and when we are doing our left to right, top to bottom, right to left, and bottom to up movement, we will adjust this row min, row max, column min, column max. Okay, when you go from bottom to top, the fourth movement, okay, you have used another column, so you increment col min by 1. Increment col min by 1. So you say col min is now 1. So all indices are 1. So basically you are just left with one element, which is this one. Okay, again you do this left to right thing. So in the next left to right movement, we cover this element 5, okay, which is the last element, and we stop when all elements are printed. Okay, again summarizing, we have 4 movements: left to right, top to bottom, right to left, bottom to top. In each movement, we are covering a row or a column, which we are adjusting using these indices that start from 0 till m minus 1, 0 till n minus 1. These are indices that you have to cover the entire matrix. These indices change as we keep complete our movements, right? We make sure not to print the same element again, and we stop when all the elements are printed. Okay, so algorithm in short looks like, while not all elements printed, okay, you have to go left to right, okay, you have to go top to bottom, okay, you have to go right to left, okay, and then you have to go bottom to top, okay, and this with starting at I equal to 0, j equal to 0, okay, and row min is 0, col min is 0, row max is m minus 1, col max is n minus 1. We start with these values. Okay, all right. And since in this case, I guess we have to return a vector, right? We have to start with an empty vector in which we keep populating these elements as and when we cover them. Okay, so the order of I and j indices that is generated with this order is the order in which we are visiting these elements, and it is in the same order that we push these elements into this vector that we have to return. Okay, so translating this into code now, as long as all elements are not covered, okay, I'll just keep while true for now, okay, at the condition left to right, top to bottom, uh, right to left, bottom to top. Okay, and we start with I equal to 0, j equal to 0. Number of rows is going to be matrix dot size. Okay, number of columns is going to be matrix of 0 dot size. Any row size will give you the number of columns. The empty vector to begin with, okay, I'll say order. All right, and we have to return the order. Eventually we push elements, okay, as and when we traverse our 2D array. Okay, so this loop means as long as we have not covered all the elements of the matrix, we continue with our spiral order. Okay, so we stop when we have covered all elements, that is, if the size of order, okay, equal to in total elements is going to be m into n. So if order dot size equal to total elements, so if the number of elements that we have added to this vector order is equal to the total number of elements in the matrix, we break. And we check this after all the movements. Okay, so we can keep this while true as it is, and we can keep checking if we have covered all the elements in the matrix after every movement, left to right, top to bottom, right to left, or bottom to top. Okay, and we discussed that you have to start with the row min, row max, col max. So int row min is 0, int col min is 0, int row max is m minus 1, int col max is n minus 1. Okay, Now we have to go from left to right, and we saw when we go from left to right, your I is constant and j increments. Okay, so while j is less than equal to col max, because this is the maximum value of the column, okay, I need to keep visiting these elements. That is, I need to keep adding these elements to our matrix order. So I'll say order dot pushback matrix of I comma j, and I increment j. All right, so in a left to right movement, whichever column we are at, we go till column max. Okay, column max, j increments goes till column max, because that is column in column max are defining our limits. All right, and all the elements that we are visiting in this row, we keep pushing it to this vector order and we increment j. Okay, when this loop stops, that is, we have covered this row, so we have to increment row min by 1, row min plus plus. Okay, and then we have this check, and then we start our top to bottom movement after left to right. Okay, you will notice that in our very first movement, okay, your I starts at 0 comma 0 here. I and j start with 0 comma 0 here. Okay, right, we are starting with I equal to 0, j equal to 0. Okay, and we go till j less than equal to column max, which is basically 2. So I and j takes value 0 0 0 1 and 0 2. Okay, the loop will break when j equal to column max plus 1. So after you have covered all these elements, your basically pointer comes here when j becomes 3. J becomes column max plus 1, column max is 2, j becomes 3. So for I equal to 0, j equal to 3, the first loop breaks. Okay, you have to start your next movement from here, which is I equal to 1 and j equal to 2. So you have to come from this position. If you think of this as an imaginary cell here, j equal to 3 and I equal to 0. Okay, you have to move to the next row and the previous column. All right, so after your left to right movement, you have to move to the next row and previous column. Okay, move to previous column, move to next row. Okay, all right, these three elements were covered, printed. When j equal to 3, the loop broke. I equal to 0, j equal to 3, you have to start from I equal to 1, j equal to 2, basically from the previous column and the next row, which we are setting here, next row and previous column, and incrementing row min, because that is the row we have covered. Okay, then this check. Similarly, when we move from top to bottom, for top to bottom, we have I increments j constant. I increments, that is, while I is less than, what is the limit of I, which is row max. Okay, and I plus plus happens. Okay, okay, and after this you decrement col max by 1. So we say col max minus minus. Okay, because we have covered a column. And similarly, okay, you end up here in this next cell when the loop breaks, when I becomes row max plus 1. So you have to go to the previous row and previous column. Okay, so before you start right to left, you have to do I minus minus and j minus minus. Okay, move to previous row and move to previous column. All right, then we check this condition, stopping condition, and then we start a right to left. In a right to left, our j decrements. So basically in a right to left movement, I constant j decrements. So we say while j is greater than equal to col min, okay, and j minus minus. Okay, and after your right to left movement, we decrement row max by 1. So I say row max minus minus. And similarly, when you are doing your right to left movement, you will stop here. So you have to start from here, which is the next column and previous row. Next column, that is j plus plus and previous row. Okay, so move to previous row, okay, and move to next column. And finally, coding our last movement, which is bottom to top, I decrements j constant. I decrements, so we can do the same thing. While I is greater than equal to row min and I decrements, okay, and after bottom to top you increment call min by 1, okay, and similarly when you're going from bottom to top your loop stops here because we adjusted the min and max for column and row indices. Your loop stops here, so you have to start from the next column and the next row. Okay, so you do I plus plus j plus plus, okay, move to next column and move to next row. Okay, you can put this here to maintain the order. Okay, so after bottom to top you adjust the indices so that the next left to right begins correctly. Okay, and that is our code. We return this order vector and it should cover all the elements of this 2D array, this matrix in spiral order. So testing this now. Okay, accepted, submitting. Okay, beats 100%. Memory is also decent. All right. Okay, and this is your solution. If you want a deeper understanding of how it is going, you should track the indices I and j. Okay, and you will understand what we are trying to do. The major points here are what I have listed here. Okay, with maintaining these row min and row min, row max, column and column max. This is making sure that we stay within the right limits. That is, once we cover a row or a column, we don't cover that again. And also a key point is making sure that you adjust the indices right when you have to start the next movement. Okay, so I hope you like this video and this was helpful. If there is any doubt, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to this channel, and thank you for watching.